resultant of two vectors ಗೆ ಫಾರ್ಮುಲಾ ಕಂಡಿದ್ದೀವಿ ನಾವು. Let's discuss different cases. The first case, P and Q are in same direction. ಏನು same direction ಅಂದ್ರೆ P and Q are in same direction, theta 0. Therefore, our formula becomes R equals square root of P square plus Q square plus 2PQ. What is cos 0? Cos 0 is 1, therefore it is into 1. So this comes out to be P plus Q whole square and a root. Therefore, R equals P plus Q. So this is the maximum resultant. So therefore we can write R maximum as P plus Q. So maximum resultant ಬರಬೇಕು ಅಂತಾದ್ರೆ P plus Q must be in the same direction. Okay. If P and Q are in opposite direction, case 2, P and Q are in opposite direction. If P and Q are in opposite direction, P higidre Q opposite angle. What is the angle? 180 degree. Therefore, theta is 180 degree. Cos 180, nange gottide. Cos 180 is minus 1. Therefore, our resultant formula R becomes square root of P square plus Q square plus 2PQ into minus 1. Therefore, it is P square plus Q square minus 2PQ. Therefore, we can show that R equals P minus Q. So, this is the minimum possible resultant. ಇದಕ್ಕಿಂತ ಕಡಿಮೆ ಇರಲ್ಲ. Therefore, ನಾನು ಏನು ಬರೆಯಬಹುದು? R minimum ಅಂತ ಬರೆಯಬಹುದು. R minimum is P minus Q. R maximum is P plus Q. Okay. ಈಗ ನಾವು ನೆಕ್ಸ್ಟ್ ಇನ್ನೊಂದು ಕೇಸ್ ಅನ್ನು ತಗೊಳ್ಳೋಣ. ಥೀಟಾ 90 ಡಿಗ್ರಿ ಇದ್ರೆ ಏನಾಗುತ್ತೆ? ಥೀಟಾ 90 ಡಿಗ್ರಿ ಅಂದ್ರೆ P and Q are perpendicular. So, theta 90 degree, cos theta is cos 90, that is equal to 0. Therefore, our R becomes square root of P square plus Q square. Very simple. So, we have to consider a different case. This is very important case. If magnitude of vector P is equal to magnitude of vector Q, and if theta equals 120 degree, P length same ಇದೆ, Q length same ಇದೆ, theta 120 degree ಇದೆ, ಆಗ resultant ಏನು ಬರುತ್ತೆ? This is resultant. Okay? So theta equals 120 degree. Cos theta ಗೊತ್ತಾ? Cos theta is minus half. Then our formula becomes R equals square root of P square is P square. Q is also equal to P, adukku P square plus 2P. Q equals P, 2P into minus half. 2 gets cancelled. Therefore, P square plus P square minus P square. Therefore, it is P. So, if two vectors having same magnitude are acting at an angle of 120 degree, then resultant is equal to magnitude of either of two vectors. So, idu bhala important. Now we tolta very important point system. Illi R maximum anna nanu P plus Q anta helide, R minimum anna P minus Q anta helide. Therefore, resultant for any two vectors P and Q, resultant always lies between P plus Q and P minus Q. Therefore, I can write R is less than P plus Q, R is greater than P minus Q, or I can say P minus Q less than or less than P plus Q. So this is, we can say if theta is 0 degree, R equals P plus Q. If theta is 120, R equals P minus Q. So this is important formula. Example, for example, we have three vectors. We have two vectors, say 5 Newton and 10 Newtons are acting at a point. Their resultant may be 4 choice ಕೊಡ್ತಾರೆ. Okay, 16 Newton, 4 Newton, 3 Newton, 7 Newton. 4 choice ನಿಮಗೆ ಕೊಡ್ತಾರೆ ಅಂತ ಅನ್ಕೊಳ್ಳೋಣ. So 4 choices are given. The two vectors are 5 and 10. The resultant of these two vectors may be, ಅಂದ್ರೆ ಹೇಳಬೇಕು ನಾವು you got to check what is R maximum, 15, R minimum 10 minus 5, P plus Q 15, P minus Q is 5, therefore resultant must lie between 5 and 15. 5 and 15 ಮಧ್ಯೆ ಇರೋದು ಯಾವುದು ಇಲ್ಲಿ 7 ಮಾತ್ರ, therefore D is the proper answer. ಈ ರೀತಿ ನಾವು ಕೆಲವು ಸಿಂಪಲ್ ಕ್ವೆಶ್ಚನ್ ಅನ್ನು ಆನ್ಸರ್ ಮಾಡಬಹುದು. Okay, now let's consider the equilibrium of number of vectors. Equilibrium ಅಂದ್ರೆ ಏನು? Equilibrium means no motion. If three vectors acting at a point are in equilibrium, means the net effect is zero. For example, vectors P and Q are acting at a point, then the net effect is R. This is the resultant force. P and Q are individual forces. If you apply a force which has magnitude same equal to R and in opposite direction, like this is minus R. This minus R is called equilibrium of R. So, if there are three forces P, Q and this, then the net effect is zero. That means the system is in equilibrium. System is in equilibrium means the body is not all moving. Okay. This equilibrium conditions are helping. So, there is a law of triangle of forces. Law of triangle of forces ಏನು ಹೇಳುತ್ತೆ? If three forces are in equilibrium, then they can be represented by these three sides of the triangle taken in order. For example, P, Q and some force R are in equilibrium, then they can be represented by side AB, P is represented in AB, Q is represented in BC and C is represented in CA, opposite direction. So, if these PQR are in equilibrium, then they can be represented by the three sides of the triangle taken in order. Reverse also holds true. If three forces acting at a point are in equilibrium, if three forces acting at a point are represented by the three sides of the triangle taken in order, then they are in equilibrium. So, for example, if you consider say P, Q and R, vector P, vector Q and vector R, so this system is in equilibrium. Net effect is zero. Now, so we can write it as, we can write a vector parallel to P with suitable scale and vector parallel to Q with the same scale like this, and R, a vector parallel to R. So then I can write P, Q, R are in equilibrium. So now here ಬರೆದಿದ್ದೀವಿ ABC. AB the length AB is proportional to P, or P is proportional to length AB, Q is proportional to length BC, and R is proportional to length AC. Therefore, we can write P by AB is equal to Q by BC is equal to R by AC. So this is the result of law of triangle of forces. Law of triangle of forces denote ಮಾಡ್ತೀವಿ. There is one more rule for the equilibrium of three forces, that is called Lami's theorem. Lami's theorem. If three forces acting at a point are in equilibrium, so for example, I will denote by P, and this force by Q, and this force by R. If angle opposite to P is alpha, angle opposite to Q is beta, and angle opposite to R is gamma, then this Lami's theorem states that P divided by sin alpha is equal to Q by sin beta, that is equal to R by sin gamma. ಹಾಗಾದ್ರೆ ಏನು ಹೇಳ್ತೀವಿ ಸ್ಟೇಟ್ಮೆಂಟ್ ಹೇಗೆ ಇದು ಹೇಗೆ ಅಂತಂದ್ರೆ P is proportional to sin alpha, Q is proportional to sin beta, and R is proportional to sin gamma. So hagadre statement is like this: if three forces acting at a point are in equilibrium, then each force is proportional to sin of the angle between the other two. P is proportional to sin of the angle between R and Q, that is sin alpha. Q is proportional to sin of the angle between P and R, that is therefore Q proportional to sin beta. R is proportional to sin of the angle between P and Q, that is sin gamma. Therefore R is sin gamma. Therefore we can write P by sin alpha equals Q by sin beta equals R by sin gamma. This is the condition for equilibrium of three forces. Lami's theorem and law of triangle of forces. Okay. Okay. Now let's consider some examples regarding this. Let's consider a force problem like this. We have a spring. A 10 kg force, 10 kg body is attached to the spring. Now some horizontal force is applied here, some force F is applied. Then what is the reading of the spring balance? If the spring balance is vertical, it reads 10 kg. If it is applied by some force F, say 5 Newton force, or you can say in terms of 10, it is 5 kg weight force. If it is displaced like this, okay, what is the effect? So for that we have to write like this. So if it makes an angle, see, this is the spring balance, this is the actual position. Now the spring balance is displaced to an angle theta. Now this spring balance is equilibrium. This is the weight acting vertically downward, W, and this is force, horizontal force. Okay, this is theta. So this is the reading of spring balance. Reading of spring balance. If this is theta, see. So now we can use Lami's theorem. This is 90 degree. If this is theta means, see, this is also theta, this is therefore this is 90 plus theta. This is 180 minus theta. Using Lami's theorem we can write R by sin 90 equals W by sin 90 plus theta is equal to F by sin 180 minus theta. Using this we can simplify. Okay.